In this video, I will describe how each of the following functions in the extrinsic control of GFR: sympathetic nervous system, renin-angiotensin mechanism, and natriuretic peptides. The extrinsic control of glomerular filtration rate by the sympathetic nervous system involves the sympathetic efferent fibers of the renal nerve releasing norepinephrine, and norepinephrine binds to receptors on the vascular smooth muscle of the afferent arteriole, stimulating contraction, and this constriction of the afferent arteriole increases resistance to blood flow into the glomerulus, leading to a decrease in the glomerular blood hydrostatic pressure, leading to decreased net filtration pressure and decreased glomerular filtration rate. So in response to a stressful situation, part of the fight or flight stress response coordinated by the sympathetic nervous system is to decrease the amount of blood being filtered in the kidneys. This will make sense if you had a stressful situation that led to bleeding. You would want to maintain as much blood volume in the circulation as possible, and it's not really necessary to send a large amount of blood to the kidneys when you're dealing with this acutely stressful situation. The renin-angiotensin mechanism provides another control over the glomerular filtration rate. This occurs when the macula densa in the distal convoluted tubule detects a decreased sodium level or a decreased flow of filtrate. This results in the production of a paracrine message, prostaglandin E2, that signals to the granular cells of the juxtaglomerular apparatus, stimulating them to produce renin. Renin is an enzyme that then activates the conversion of angiotensinogen to angiotensin. So angiotensinogen is constantly being produced from the liver, and renin activates it in the first step to form angiotensin 1. Angiotensin 1, though, is not completely activated until it flows through the pulmonary circulation, where the angiotensin converting enzyme catalyzes the next step in activation, converting angiotensin 1 to angiotensin 2. Now, angiotensin 2 gets its name from the fact that it stimulates vasoconstriction. This occurs all through the body where arterioles constrict, but within the kidneys, vasoconstriction of the efferent arteriole leads to an increase in the glomerular filtration rate. So as a mechanism to regulate glomerular filtration, angiotensin increases GFR, and this works to help stabilize your overall glomerular filtration rate in the face of something like a decreased blood volume. Having a low blood volume or a low sodium concentration and a low blood pressure itself would be a factor that could inherently decrease your filtration, but having angiotensin cause constriction of the efferent arteriole increases GFR to help maintain homeostasis. Atrial natriuretic peptide, or ANP, is a hormone that's produced by the heart when there's an increase in blood volume. This leads to stretching of the atria, and then the atria of the heart secrete the atrial natriuretic peptide. Atrial natriuretic peptide is a potent vasodilator, which causes dilation of the afferent arteriole. As the afferent arteriole dilates, this leads to increased pressure within the glomerulus, stimulating an increase in the glomerular filtration rate. So as we have an increased filtration, this will help us to remove liquid from the blood, helping to restore homeostasis. Producing an increased filtration will help to decrease plasma volume.